This is section 2.9 in your textbook on solving inequalities. You should have seen this before at some point in another math class, so this should be review and refresh, but I will teach it fairly much from the beginning, just in case you haven't seen it in a long time. So inequalities are when you have these symbols, less than, greater than, less than or equal to, and greater than or equal to. Hopefully you've seen those before. The ones that point to the left are less than, and the ones that point to the right are greater than. And we'll talk a little bit more about that as we go along. Inequalities solve just like equations unless you divide by a negative. You could also multiply by a negative. That doesn't happen very often, but the same thing is true. If you divide or multiply by a negative, when you do this, you switch the symbol from greater to less than or vice versa as you do that. So anytime you divide or multiply by a negative, most of the time it's dividing. Every now and then you'll multiply by a negative. You turn the sign to face the other way. While you're solving, and I think I have this on the next page, I'm going to write it down here and we'll talk about it again. Keep variables to the left and constants to the right. Normally when you solve an equation, you can solve however you want, but for inequalities, we read left to right, so we want to keep our variables to the left and our constants to the right, which is generally true. They're generally set up that way, but we'll see a few later on where you really want to be mindful of that so your inequality doesn't get all mixed up. So this inequality, 3 times x plus 1 is less than or equal to 18. We're going to pretend this is an equal sign, solve for x like we know how to do, unless we divide or multiply by a negative. So I'm going to go ahead and distribute that 3. That's 3x plus 3. We're going to leave the symbol alone, keep it the same way it was. Don't change that unless you have to. Then we'll move the 3. 3x is less than or equal to 15. And then we will divide by 3. And x is less than or equal to 5. That is your inequality statement. X is less than or equal to 5. But there are 2 other ways to write the same expression. And so this is the inequality notation. They're going to ask you to graph it on the homework, and that's to give a visual of what this expression means. And from the graph, we're going to write it into what's called interval notation, which might not be as familiar to you, and we'll go through that in each example. So on your number line, you don't have to mark out every single number. Just kind of find 0 in the middle. 5 would be somewhere over here. It doesn't really have to be to scale as long as it's accurate. As far as positive and negative, that's all I really care about. It's less than or equal to 5. On a number line, positive infinities to the right, so bigger numbers go to the right, and negative infinities to the left, so smaller numbers go to the left. So because this says less than or equal to 5, we're going to draw a bracket. A bracket is a parentheses with sharp corners, so a sharp bracket. It's going to open to the left for less than, and your arrow is going to go to the left for less than. So less than goes to the left. Remember that L, left, less than. And greater than goes to the right. I know I wrote that pretty tiny, but you'll get the idea. Greater than to the right, less than to the left. Some textbooks that you might have seen in the past use a closed circle and then an arrow. The reason we're filling in the circle or making a sharp square bracket is because there's a line underneath the inequality. We'll see an example of each type here, so don't jump too far to conclusions yet. We'll look at each one and then you can see the pattern. So that's your graph. It starts at 5 and goes back to negative infinity. Interval notation always goes left to right. You're basically listing the smallest possible number and the biggest possible number in the interval. So the smallest possible number here is negative infinity, and the biggest possible number is 5. Infinity always gets parentheses because it never ends. And then the 5, because we drew a bracket here, we're going to put a bracket here. And you don't need to draw those lines underneath. That was just for spacing. So negative infinity, comma, 5. That is interval notation. And again, if you're not too familiar with that, let's go through all 4 of these examples, and you'll pick up the pattern as we go. So let's look at example 2. Again, we're going to solve this just like an equation. I'll distribute my 4. 12 plus 4n is greater than 32. I'm going to move my 12. 4n is greater than 20. Divide by 4. Now we're dividing, but we're not dividing by a negative, so we have no troubles. We're going to leave the symbol the same. N is greater than 5. This time it's greater than, so it's saying that we're on the right side of 5, or the greater than side of 5. So again, 0 somewhere in the middle, 5 to the right. There is no line under this inequality, so we're going to use a parentheses, a curved parentheses, instead of a bracket. So bracket goes with a line underneath, parentheses goes with no line underneath. It's going to point in the greater than direction towards positive infinity. Other textbooks use an open circle with an arrow to the right. Either way is fine, but in your homework you're going to see the parentheses. Interval notation, again, kind of picks up the graph and states it left to right. So it goes from 5 to infinity. Infinity always gets a parentheses, and because we put a parentheses on the 5, we'll put a parentheses on the 5 here. So it's always left to right, whether it's less than or greater than. That part doesn't matter for interval notation. It's always left to right. Negative infinity will always be on the left, and positive infinity will always be on the right, depending on which way you drew your arrow. And again, that's a little tricky, but you'll get used to it. It just takes some practice, and you'll start to see the pattern. Let's look at example 3. We're going to solve this just like an equation. I'm going to go ahead and add 3 to both sides. X over 3 is less than or equal to 18. From here, again, different things you can do. I'm going to multiply both sides by 3. And what that does is cancel out that denominator of 3. And I get x is less than or equal to whatever 18 times 3 is, 54. I'm sorry, I put 18. That is wrong. 6 plus 3, which is 9. And 9 times 3 is 27. I multiplied instead of added. There we go. So x is less than or equal to 27. We'll put 0 in the middle, 27 somewhere over here. Less than or equal to, so less than goes to the left. Because it has the line underneath, we're going to draw a square bracket and draw an arrow to the left. If you're used to the open and closed circle, that's fine, but this particular textbook uses brackets and parentheses. So that's what we should practice using just to be consistent with our homework. And then the interval is going to go from negative infinity to 27. 27 will get a bracket. Infinity always gets a parentheses. Example 4. Again, we're going to solve. I'm going to move that 5. Negative 2x is greater than 12. I'm going to divide by negative 2. Now here is where we are dividing by a negative. When we do that, which doesn't happen very often, but when we do that, that symbol that was opening to the left is now going to open the other way. Nothing else changes. The math stays the same. Everything stays on its side. You just turn that symbol the other way. Then you have 12 divided by negative 2, which is negative 6. So it becomes x is less than negative 6. So again, 0 in the middle, negative 6 is over here. Less than goes to the left. There's no line underneath, so I'm going to open to the left with a parentheses and draw an arrow towards negative infinity. My interval is going to go negative infinity to negative 6, parentheses to match that, and parentheses on infinity. So I would say interval notation is the hardest part of this. Just practice. There's some extra practice on in my math lab. I can send you extra practice if you need to. You can just email me. Just practice that interval notation. All right, example 5 is an expression, an inequality written in words. So let's kind of translate that to a math expression and then we can solve it. It says 3 more than twice a number is less than negative 17. So 3 more than would be 3 plus, twice a number would be 2x, we like to use x for our variable, is less than, so less than negative 17. So we're just translating that English into math. It's usually pretty easy just to read through and translate. Some of them get a little trickier, but I try to keep them pretty straightforward. Now that we have an expression, we can solve. 2x is less than negative 20, divide by 2, x is less than negative 10. So even though there's a negative over here, what we're dividing by is positive, so nothing changes. So x is less than negative 10, 0, negative 10's over here, less than goes this way, arrow towards negative infinity. Again, just practice that, it's not too bad. And our interval is negative infinity to negative 10 with parentheses on both. So those are just kind of your basic inequalities here. They can get a little bit more complicated with variables on both sides. This is where keeping variables to the left comes in handy. So when there are variables on both sides, keep variables to the left and constants to the right. And this way your inequality reads properly from left to right. So variables left, constants right. You don't want to get all that switched around. Some students can read it from right to left, but it's awkward. We were all trained to read left to right, so that's what your brain wants to do. So just for that consistency, we'll always do that. So we're going to move variables left, we're going to move constants right. So I'm going to move that 7 to the right. 2x is less than or equal to x minus 18. Then I'll move my variable to the left. 2x minus 1x is just x. It's less than or equal to negative 18. So that way it reads properly and you don't have to read it backwards. So x is less than or equal to negative 18. And then same idea with your graph. Less than or equal to would be a bracket pointing to the left, which is the negative infinity direction. So negative infinity to negative 18, bracket on negative 18, parentheses on negative infinity. If you'd like to pause the video and try the next few, or you can try the next 3, and then play it back, or you can just continue to follow along with me. Example 7, again we're going to keep variables left, constants right. So I'm going to move my 20. 3x is greater than or equal to 2x minus 7. Move the 2x. 3x minus 2x is x. Is greater than or equal to negative 7. So always throw 0 in the middle. Negative 7 would be here. Greater than or equal to would be a bracket to the right. Arrow in the greater than direction towards positive infinity. So we have negative 7 to positive infinity, bracket on negative 7, parentheses on infinity. Example 8, we'll go ahead and distribute. Negative 5x plus 7 is less than 2x minus 6. We're going to move that 7. Negative 5x is less than 2x minus 13. We'll move the 2x. And again, there's lots of ways to solve this, but if we can keep our variables left and our constants right, it makes the end result easier to follow. So we have negative 7x is less than negative 13. I'm going to bring this down here because I ran myself out of room. Let me write it again. Negative 7x is less than negative 13. So when I divide by a negative, the symbol's going to change. 13 does not divide nicely by 7, but the negatives do divide off. So it's going to be 13 over 7, positive 13 over 7. And my less than symbol switched to a greater than symbol. You don't really need to know where 13 over 7 is, just know that it's positive, just to throw it on the number line appropriately. Greater than would be a parentheses to the right, arrow to the right, towards positive infinity. So we have 13 over 7 to infinity with parentheses on both sides. And then example 9, again, distribute. 6 minus 5x is greater than 3x minus 12. From here, we're going to keep our variables to the left and constants to the right, so I'm going to move that 6. Like I said, lots of choices there, but you want to keep that consistency. Negative 5x is greater than 3x minus 18. Oops, move your 3x. I got ahead of myself there. You'll get negative 8x is greater than negative 18. I'm going to bring it down here. Divide by negative 8. X is greater, not greater. So because we're dividing by a negative, we're going to switch it. Negative 18 divided by negative 8. The negatives cancel. 18 over 8 is not a nice number, but you can at least reduce it to 9 over 4. So you can cut them both in half. So it's going to be x is less than positive 9 over 4. So there's your 0. There's your 9 over 4. Less than, and go to the left. Point to the left towards negative infinity. And your interval would be negative infinity to 9 over 4 with the smooth parentheses. So again, they can get a little complicated, so just keep up with where you're working and keep variables to the left, constants to the right. The last part of section 2.9 is on compound inequalities, and that is when you have an expression in the middle and values on both sides. They look more complicated, but they're really not. You solve each side at the same time and keeping your variable in the middle. So it looks more confusing, but it's really not too bad. So we're trying to solve for n. If I covered up this part of the inequality, I would subtract 9 from both sides. If I covered up this part of the inequality, I would also subtract 9 from both sides. So we're going to subtract 9 from both sides at the same time. So we're going to subtract 9 from the middle, subtract 9 from the right, and 9 from the left. The middle cancels out. Negative 1 minus 9 is negative 10. I'm going to keep my symbol the same. N stays in the middle, and 17 minus 9 is 8. So what this is saying is that n is between negative 10 and 8. The symbols are a little funky with the variable in the middle, so it reads a little weird. But that's what it means. It means your variable can be any number between negative 10 and positive 8. So this time on our graph, we have negative 10, we have positive 8, and the inequality is going to face each other. So they're both less than, but they're going to turn in and face each other. And there's no lines underneath. So the parentheses are going to face in to show between. So that's how we show between on a number line, and we just connect between them. So that's just showing any number between negative 10 and positive 8. There are no infinities here, there are no arrows at the end, it's just between negative 10 and positive 8. So the interval looks the same, negative 10 to positive 8, and there's no infinity symbols here. So that kind of weird to get used to, but it's really not too bad. Same thing on example 11, we'll add 22. to the middle, the right, and the left. 2 plus 22 is 24. We leave the symbol the same. 6 plus 22 is 28. Then we divide everybody by 4. So we're going to have 6. We're going to leave the symbol the same. We have x in the middle. Leave the symbol the same, and then 7. So it's just saying that x is between 6 and 7. And because there's lines underneath both of those, we're going to use brackets, and they're going to face each other. So it's just going to be 6, 7. So no infinities here, just facing each other. Same idea on example 12. Here I'm going to multiply by 5, multiply by 5, and multiply by 5. What that does is cancel out that dividing by 5. I'm left with negative 5. It's less than or equal to negative 3x plus 4 is less than or equal to positive 5. And again, I'm trying to solve for x. I'm going to leave the variable in the middle. I'm going to move that 4. Negative 9 less than or equal to negative 3x less than or equal to 1. Here I'm going to be dividing by negative 3. When I do that, the symbols are going to switch. Let me write it again so you can see it better. When I divide by negative 3, negative 9 divided by negative 3 is positive 3. This symbol is going to turn and face the other direction. X is still in the middle, it's still between. This symbol is going to turn and face the other direction. And positive 1 divided by negative 3 is negative 1/3. In doing this, we've turned the whole thing around, the positive numbers on the left and the negative numbers on the right, which in our minds is backwards. So when we go to put this on the number line, we have to draw it proper to the number line. So negative 1/3 is over here, positive 3 is here. X is still between them, so we still put brackets facing each other, and they still connect. None of that changes. This is just funky looking because of the way the numbers worked out. Your interval, though, still puts your negative number first and then your positive number. So it has to go from left to right, even though this one kind of reads backwards. And you can turn this whole thing around. If it's kind of hard to show on a video, but if you think about a mirror reflection, you can turn this whole expression around. I'm not changing anything. I'm just turning it the other direction. It was facing this way and now it's turned. So that's a little confusing on a video, but all you need to know is that x is between the two numbers, and that's all there is to it. Last but not least, example 13. The first thing you want to do is to multiply everybody by negative 3. This is one of those rare cases where we're multiplying by a negative, but the same principle is true. So this is going to be 12. That symbol is going to switch to face the other way. 2x minus 5 doesn't change because those just cancel. And this is going to turn and face the other way as well. And then you'll solve like normal. So I'm going to add 5. 17 is greater than or equal to 2x. Greater than or equal to 2. Divide everybody by 2. I'm going to bring it down here so you can see it. 17 over 2 doesn't divide, so we'll just leave it. Symbol is greater than or equal to. X is in the middle. And 2 divided by 2 is 1. Now